So here is the first question. Find the derivative of tan inverse of root x with respect to x. Now here we don't see any specific pattern, so no need to have any substitution, and we will directly differentiate using the standard formulae. And here we observe that tan inverse function is present, and inside that we have square root of x. So we will have to use the chain rule to differentiate. So if you want, let us call the given function as, say, y, that is y equal to tan inverse of root x. Therefore, to differentiate y, see here, to use the chain rule, let us visualize that we have tan inverse of something. Okay? If it were tan inverse of just x, then its derivative would have been 1 upon x square plus 1. Right? But here it is something other than x, which is root x. So we'll have to further multiply by derivative of root x using the chain rule. So to begin with, let us write the standard formula, that is derivative of tan inverse of root x is 1 upon root x square plus 1, right? You can relate it with this. So whichever number is here, we'll have to put its square, then plus 1. Now that has to be multiplied with the derivative of root x, which is 1 upon 2 root x, as we know. So simplifying this, we have 1 upon root x plus 1 is nothing but x plus 1 into 1 upon 2 root x. So you can just write simply as it is 2 x plus 1 into root x. That's it. So that's the final answer. Let's see one more question. Find the derivative of cos inverse of 1 minus x square upon 1 plus x square. Now here, if we try to directly find out the derivative of cos inverse using the standard formula and the chain rule, it will be too tedious, isn't it? Because this particular quantity involves the division. So instead of that, let us try to think, can we do any substitution? Are we seeing any particular pattern? So we'll see that yes, we definitely see a pattern, that is 1 minus x square upon 1 plus x square. And where does this pattern come into picture? If you remember, we have the formula as 1 minus tan square theta upon 1 plus tan square theta is nothing but equal to cos of 2 theta. That's the double angle formula for cos, right? So therefore here it will be fruitful to put x as tan theta, right? So let us consider first, say y is equal to cos inverse of 1 minus x square upon 1 plus x square. Then we say let x be substituted as tan theta. So therefore our y will become cos inverse of 1 minus tan square upon 1 plus tan square theta. That gives us cos inverse of, now we know that this bracket is nothing but cos of 2 theta. Now assuming that this 2 theta lies in the principal value branch, we can nullify cos inverse with cos, isn't it? Because they are the inverse operations. So therefore we can put y as nothing but simply 2 theta. Okay. Now as theta is our own variable, it's not given initially, so we must replace theta back in terms of x, correct? So y is equal to 2 into, now what is theta? For that, let's look here. X is equal to tan theta, so theta is nothing but tan inverse of x, taking tan on other side. So here we replace theta with tan inverse of x. And now to differentiate y with respect to x, we can easily do that because we know the derivative of tan inverse, which is a standard function. So it is 2 into derivative is 1 upon x square plus 1. That's the final answer, which is 2 upon x square plus 1. So this is how we have to identify the pattern and only then use the substitution for simplifying the process of differentiation.